For this section, we're going to talk about arithmetic sequences and partial sums. So you should recognize a few words from this title, and we're going to talk a little bit more about sequences and more about sums. So let's take a look at this first example. So you see I have a sequence. It starts off with 5, and then we have 8, 11, 14, 17, and so on. Now, the thing is this an arithmetic sequence? Now, remember, the word arithmetic basically looks like arithmetic, and in arithmetic, all you did was add, subtract, and all that stuff. So, arithmetic sequences basically are when you have a sequence, but what's special about it is every time you get to the next term in your sequence, you're always adding by some value. And notice I'm using the letter D, because I'm saying, oh, the difference is this. So you're going to add D to get to the next term. So to get to A sub 5, I would add D to A sub 4. So back to the example above. Is this sequence an arithmetic sequence? Well, let's see. So to get from 5 to 8, I add 3. Okay. To get from 8 to 11, we add 3. We add 3 here, and we add 3 here. So with the terms that they've given us so far, yes, this is an arithmetic sequence, and the difference in this is we add 3 each time. So then, can we generalize this? I mean, if you take a look, in this arithmetic sequence, it's actually infinite, right? Because I have this dot, dot, dot thing, meaning it's going to continue on and on. So is there a way such that I can rewrite this that, for any n, so for like any one, like if I want to go all the way out to the 30th term, can I figure out what number I would be given? I mean, I don't want to add 3, I don't want to add 3, then add 3, then add 3, then add 3, and add 3 until I get to 30. I mean, that would take me for a really long time, and we're pretty good at math, so I think we can come up with an equation such that we get this, such that I can get. So to get the nth term, we're going to use this, this little equation here. To get a sub n for any n, it could be 30, it could be 60, it could be anything. It will be d times n minus 1 plus a sub 1. Where d is the difference, like from here, okay? That's what that d means. And then the n represents the term number we're using. And a sub 1 is our first term. So for the example above, a sub n will equal 3 times n minus 1 plus a sub 1 is 5. Now I just want to double check to make sure that this is true, okay? So if I want to check for the third term, or let's try the fourth term. This is term 1, 2, 3, 4. So a sub 4 will equal 3 times, well, n in this case is 4, minus 1 plus 5. That will be 3 times 3 plus 5, which gives us 9 plus 5, which is 14. So yes, this equation checks out. So once again, I did this orange stuff just to make sure that my blue equation works out. And it's always a good idea to do that, just to double check. Now remember, I wanted to know from above, I want to know the 30th term. So all we have to do now is plug in 30 for n and see what we get. Turns out it will be 92. So right here above, we can fill this in to be 92. Okay, so now let's look at this example. We're asked to find the 10th term of this sequence. Well, first of all, we have to make sure that it's arithmetic. Okay, so you know how in the last example it was really obvious that every time we were adding 3? Well, it's not as obvious what we're adding here, right? I mean, we're dealing with fractions. So another trick that we can do is, what's the opposite of adding? Well, subtracting. So let's work backwards. What's 7 over 6? Subtract 1. Well, that's the same thing as 6 over 6, which means that difference, what we did here, is we would add 1/6. Okay, so we want to play the game here as well. What's 4/3 subtract 7 over 6? Well, common denominator, and you get 2 over 2, which you get 8 over 6 minus 7 over 6, which gives us 1/6. So once again, we add 1/6 here. And just to triple make sure, let's find the difference here. So 3 over 2 subtract 4 over 3. We get 9 over 6 minus 8 over 6, which is 1/6 as well. So we've checked, and this is good, and I'm sure this is 1/6 as well. So that's another way to check your differences. You work backwards. You take a term and minus the term from before. Like, we took this term, and we minus the term from before. Okay, so in our form of a sub n equals d times n minus 1 plus a1, we can fill in the d now. So we know that a sub n is equal to 1 over 6 times n minus 1 plus 1, because that's what we started off with. And since we want the 10th term, all we have to do is replace wherever we see n for 10, and we'll get the 10th term, which we end up getting as 15 over 6, which reduces to be 5 over 2. So the 10th term is, so we're given a sub 4 is 20, a sub 13 is 65, and we're asked to list the first 3 terms. Okay, so this is slightly different than the other ones, right? Because the other ones were given the first few, and then we figured out the equation. But you know what? You guys are still good at math. This is, if you haven't noticed, this is basically just kind of like linear equations. So where basically our d value is kind of like our slope, and our a sub 1 is our y-intercept. I mean, it's kind of like the same idea. So you know what we're going to do? I'm going to find the difference between every term. But how am I going to do that? Well, take a look at this. I know that I can take a sub 13, the actual value, minus a sub 4. And then let's divide that by the actual n value. So 13 minus 4. And doesn't that look like the equation of the slope? So we're using our y's divided by our x's. Okay, so we get 65 minus 20 divided by 9, which gives us 5. And to fill in our equation, we know our d now. We don't know a sub 1, but that's okay, we'll figure that out. However, I do know at least 2 things. I know that at a4 we have 20, and at a13 we have 65. Well, guess what? That's enough information to help us out. Because what we can do now is we can fill in this to be 65. And that was for a13, right? So then we can fill in n here to be 13. Solve the equation for a sub 1. And turns out a sub 1 is also equal to 5. So now if we fill in our equation from above, we know that a sub 1 is 5. And we can fill in d as well, which we knew was 5 from the above. And now I can fill in, or answer the question, what's a sub 1, a sub 2, and a sub 3? And what we should get is 5, 10, and 15. And we get that from plugging in, and we change it every time for these n values.